Vitamin A is one of those nutrients where popular nutritional understanding and biochemical reality are frustratingly misaligned. Most people understand that vitamin A is important, associate it vaguely with eye health, and believe that eating plenty of orange and yellow vegetables adequately addresses their needs. The reality is more complicated, and for a meaningful portion of the population, potentially a majority, the assumption that plant-based beta-carotene reliably converts to vitamin A in sufficient amounts is simply not supported by the evidence. The distinction that matters here is between preformed vitamin A retinol found in animal foods like liver, eggs, and full-fat dairy, and provitamin A carotenoids, primarily beta-carotene, found in plants like carrots, sweet potatoes, and leafy greens. Both are referred to as vitamin A in nutrition labels and dietary guidelines, but they are biochemically different, and the body's ability to convert beta-carotene into the biologically active retinol varies enormously across individuals. Average conversion ratios for beta-carotene to retinol are often cited as approximately 12:1 when measured from whole plant foods, meaning 12 micrograms of beta-carotene from food yields approximately 1 microgram of retinol equivalent. But this average conceals a range that extends from 3:1 in individuals with highly efficient conversion to 28:1 or worse in those with poor conversion. Genetic variations in the BCMO1 gene, which encodes the primary enzyme responsible for beta-carotene cleavage, are present in a significant fraction of the global population and can reduce conversion efficiency by 40 to 60%. Low thyroid function, fat malabsorption, zinc deficiency, and dietary fat restriction further compromise conversion. This matters for eye health, immune function, and the integrity of epithelial tissues, skin, gut lining, respiratory tract, all of which depend on vitamin A for cellular differentiation and renewal. In aging populations, where thyroid function often declines and fat absorption may be impaired, the assumption that vegetables are meeting vitamin A needs becomes particularly unreliable. Liver is the single most concentrated source of preformed retinol in the food supply, and incorporating small amounts, even 1 to 2 ounces per week, into the diet provides a reliable and substantial contribution to vitamin A status. Eggs and full-fat dairy, while less concentrated, offer consistent smaller contributions that accumulate meaningfully across a week. A critical warning is necessary here. Preformed vitamin A is the form associated with toxicity at high doses, and this risk is real. Chronic intake of liver at very high levels, or supplementing retinol at doses above the upper tolerable intake of 3,000 micrograms per day, can cause hypervitaminosis A, with symptoms including bone pain, liver damage, and birth defects if exposure occurs during pregnancy. For pregnant women, high liver intake carries a genuine risk of teratogenicity. This is a case where the correct guidance depends on population. Modest regular liver intake is safe and beneficial for most adults, but it is not the right recommendation for pregnant women, who should be counseled specifically about retinol upper limits.